why we need a set of supporting protocols. I just for the supporting protocols, I have classified the supporting protocol into 3 categories for IPv4. We just focus on IPv4. The first is the addressing protocol, how to allocate the protocols handle assignments and management of IP address. Example including the address resolutions protocols, ARP, and which map IP address to MAC address. Try to link IP address and for example, this is how to link or map the student name and student number. And also the dynamic host configuration protocol, which dynamically assigns the IP address to each device to connect to the network. So the features of DHCP is to help the users to dynamically connect it to without the need of manually set it up. Right? Okay, I need to know the IP address. I need to change the configurations before I can resolve it. Nowadays, everything is very simple. Just click authentication, input username, password, done. There's no need to do any configuration. The second category is about some syndrome for some syndrome. This like the protocol in QoS protocol. This protocol are used for testing or troubleshooting networks, connectivity, performance, and common examples of this protocol include the Internet Control Message (ICMP), which is used for error message and diagnostics by ping command, and trace route protocol, which help identify the path package and take through. So the purpose of the second category is testing and troubleshooting. That's the main function of this applications of this. The third category is the routing. Routing protocol, in short, is to make sure that the devices can find the best way to send the package from the sender to the receiver. Previously, I said that when the package need to be sent from sender to receiver, right? We will go to multiple hops. But which way they which hop or send this package to the receiver? Generally speaking, there are multiple ways or multiple solutions or multiple paths. So this protocol facilitates the routing of package between the different networks, and they determine the best paths for data to travel to make sure that the communication time will be the minimum. And the examples including the routing information protocol, RIP, and for the gateway protocol. They also for different application scenarios, like the same as the TCP. Which protocol is better? Well, it depends on the application. So I will introduce some protocols or introduce protocols will be related to school. And the first one is the ARP. ARP is the address and resolutions protocol. But it's very weird because this protocol somehow lies between the network protocol and also between the network layer and also the physical layer to clearly introduce something in the physical layer or link layer. I prefer to move the introduction of this one to the next lecture. So we will move to the second one. The second one is the DHCP protocol. DHCP. So in DHCP protocol, we need to know there's a router, gateway, and the gateway is networking devices, and this is sometimes devices already connected to the internet. And now this gateway will help other or multiple devices to connect to you. So it means that it will serve as a point of access to or allowing a set of devices or helping a set of devices to connect it, communicate with the external network or the worldwide. So that's sometimes called routers at home. And it acts as an intermediary between the local networks and because we use this function to facilitate data transfer, enabling devices to send and receive information outside their own network. That's the purpose of this kind of So the assumption that suppose we have a gateway, right? And this gateway is able to communicate with the internet. Now, how can we have another network based on with the help of this gateway? It means that this gateway is going to create a so-called local area networks and manage all these devices to connect with the internet. But the first question is that how to assign an IP address to each devices and this gateway management. And for the DHCP protocol, okay, and how does the DHCP protocol works? It's for communication purpose, okay? So national security, everything we speak over this protocol will be honest, supposed to be honest, or assumed to be honest. When the devices connect to the internet, it means that the device would like to connect to the internet. It sends the DHCP, sometimes called the discover message, to find available server. It sends some. Just broadcast this one to anyone who can receive this kind of message, called discover message. And because the server is also monitoring this kind of message, right? The server will respond after receiving this kind of request or discover message. The server will respond with an offer. And this offer will specify available IP address and other configuration information. Some kinds of IP address and also some kinds of how to set up the configurations or some other information to make sure that with the help of this IP address and other information, this new device can connect. After receiving the offer, it's going to need to sign, accept, or reject. So the client will send a request or confirmation to accept the offer. After accepting the offer, the server will send a HTTP to confirm that this assignment is done. So actually, this is the high-level description of DHCP protocol. This dynamic allocation helps manage IP address space efficiently, as device can receive a different IP address each time when it connects. An unused address can be assigned to other devices. Suppose we just use this one as the example. This is the as the example. Suppose this device can somehow support the connection of 10 devices. It means that when on the first day, when these devices are somehow connected to this gateway, the gateway will assign IP address from 1 to 10. And on the second day, maybe another 10 devices will try to connect to this gateway. But it's fine, because on the second day, this gateway step assigned with the IP address from 1 to 10 to make sure that all these devices can connect to. That's why it's somehow called a dynamic, because it means that for the same devices, when you try to connect to a gateway, your assigned IP address could be different, or could be the same, but mostly it should be different. And this is just the wording-based protocol, and this is more like interactions. So we have the client, we also have the server, and first is the client will broadcast the DHCP discover, and then the server will reply with an offer, and then the third one is confirmation request to accepting the offer, and then the last one is confirmation for the server. So and in human language, for this kind of protocol, in human language is something like the bottom English, right? First is that the client will ask, can anyone give me the address? And then the server, yes, of course you can. Here is the IP address you can use. So this is IP address including some information. For example, the gateway of IP address. And then after receiving this kind of offer, client will say, oh yes, I really want to use this IP address. Are you sure I can use it? Or I want to use it. And then the server doesn't reply, yes, you can use it, and confirm that this has been set and ready and for you to connect with this IP address. So this is the DHCP protocol. So it means that this communication is based on the real, based on honest communication. Means that the response who can give you this offer should be from the server, yes, from the server. But in the real world, when there is an adversary, or naughty adversaries, well, you can somehow annoy this kind of DHCP. So the vulnerability is that DHCP spoofing is a type of network attack where an unauthorized or DHCP server is set up by an attacker on the network. Because it means what? The attacker pretends to be the server. When the new device is trying to connect it to the network, the naughty attacker trying to send some kind of fake information. This rogue server can respond to DHCP request from the client instead of the legitimate server. Try to perform as the server. And also, most important, send some fake or get some fake offer. Now, first that when the client sends a request, or when the devices connect to the network, it sends a discover message to the local server. But this kind of naughty or malicious attacker try to respond with an offer that includes a malicious or incorrect the IP address, the network configuration settings. And once the client accepts the offer, the computer itself is the setting provided by this kind of setting provided by this malicious server. I believe this is from the legitimate. Eventually, the most important impact is that if the kind of IP address is some kind of fake, wrong one, it means that this kind of client can never communicate with the gateway because all cannot receive any packet. And this is called the network interception. Another one is somehow denial service attack. This somehow is more advanced is that the offer or the IP address somehow belongs to someone, and that will transfer or the traffic to the victims to reject in this kind of analysis. But the most obvious impact is the internet network interception. This cannot, the new client or new device cannot access to it if the attacker will try to impersonate their server. And this is the role of DHCP protocol. sure that each device can automatically connect to it. The consequence is that we could have some kinds of issue about the connecting issues when the knowledge of the managers external impersonate creating fake one. The second protocol I would like to introduce is the ICMP, Internet Control Message Protocol. It's a core protocol of the Internet Protocol Suite, primarily used for sending error messages, sending or reports. You cannot say sending incorrect message, but sending message related to or to report errors and operational. It operates at the network layer. It's essential for network diagnostics and management. And the key functions, there are two key functions. The first function is the so-called error view. And the second one is the network diagnostics. In the first function, it communicates issues like virtual destinations, or delivery, and other activities. Because the administrators need this kind of information to identify what zones of the network connection. They need to fix it. But the way to fix this kind of network connection issue, they need to know some information. And this will help the people to fix the network connection. The second one is it provides tools for network troubleshooting and performance monitoring that allows administrators to assess the network health. For example, it can run different configurations, also to calculate the time cost for the data for the IP package copy within the host. And one of the most well-known functions inside that application is called the PIN utility, which is used to test the reachability of the host. About this kind of PIN command, when the users issue the PIN command, the device should send an ICMP echo request to the target action. This is means that this is just a testing method trying to connect to another receiver, another target receiver. If the target device is reachable and operational, this device should automatically respond with reply. And this thing to check whether a particular IP address is active or not. To check on if it's offline, yes, we'll do something. And he also measures the time it takes for the echo request to reach the target and for echo reply. So it will calculate how much cost it takes and also the time to time cost. And they eventually provide indications on network connections. And this is the functions of PIN. And here I just also provide a very simple actions for this kind of ICMP protocol. The first day you send the echo request and then we supply with the echo reply. In English, there's something like are you there? So if that receiving devices or the receiving IP address is still there, yes, it will automatically write I am here. So the vulnerability behind or related to this protocol is that this PIN protocol is set the default options that it should unconditionally or automatically answer the echo request message. Should automatically answer this kind of echo request message. So it means that no matter who sends this kind of echo request to me, I should automatically send the reply if I'm online. And this is some kind of setting or mechanism inside the ICM. And because of this, there will be protect. And this kind of automatic answer or unconditional answer is somehow different from that kind of flooding attack inside the TCP. Inside the TCP protocol, it means that because of the attack will not finish the handshake. And just because that the server has allocated some kind of memory waiting for HTTP from the client to complete the handshake. But the client will not finish this. And this is something that automatically reply. So I mean that the principles behind this kind of vulnerabilities are not identical. Okay, and who has the attack? There are two kinds of attacks. The first attack is the flooding attack or denial service attack. Well, this kind of denial service attack has been used in many times for people of different purposes. Attacks can send a large number of ICMP echo requests or packages to overwhelm target system leading to degraded performance or complete unresponsiveness. So this can cause significant network disruption, making service unavailable and impacting overwhelmed network stability. And this is somehow the detail also another attack trying to use this kind of protocol to launch the denial service attack. For example, again, I have control or as I am students mobile devices. I will send a command and force all these devices to send an ICMP echo request to UW server. All devices will send this kind of ICMP echo request. And then the UW web server or UW server will receive 1 million of these kinds of echo requests per second. And then the server needs to reply to this kind of reply with the ICMP echo reply message to 1 million devices per second. And this will that's why you consume the server's resource and making the service available. And that's why it's called flooding and denial of service. And the second attack is somehow different from field denial of service attack. It somehow uses some kinds of tricks behind the mechanism of ping service, and the name is called ping attacks. They somehow trying to use the bugs, the security bugs of system. It's trying to exploit some kinds of vulnerabilities in the system's handling of oversized ICMP packets, which can cause some crash. This is just because when in that kind of ICMP echo request message, generally speaking, it should be short because there's nothing inside. It's always just be a short package. That's because there's no need to have any data or payload inside this kind of echo message. So it's assumed to be very, very short, right? But after receiving, it's assumed to be short. After receiving that kind of request, the system should take it, understand it, take it as input, and then generate some kind of reply message. And now, how to do the reply, how to do the ICMP, the echo reply. It's somehow, yes, this is based on the system, but during the implementation, that operating system could implement the reply message in the wrong way, or didn't fully implement the reply message correctly. And it will receive, for example, it will not check the size of ICMP package, and it will keep receiving. And here, the sender says, okay, that's the end of the echo request information. And this one, you will receive, you will become an oversize. And you have some kind of issues. And that issue is somehow will lead to this kind of operating system crash or reboot, affecting the availability and the reliability of the network services. It's just because the size is large than the restrictions. The package size is larger than the restrictions. And yes, and this are the vulnerability of ICMP. Okay, now I hope you know that. Now, designing a good operating system is not easy, because not just to make it to guarantee that it works, and also to make sure that it's somehow secure. The implementation of operating systems consider lots of details. For example, how to implement the protocol correctly. If the system didn't check the size of the package, that system could suffer from the call, the attack called ping of death. Yeah. And okay, this is the second protocol. Now we go to the third protocol. It's called RIP, Routing Information Protocol. And we will not explain how the routing works, okay? Because the routing, the detailed routing mechanism is really it's more about inside the network communication. Because talk about some kinds of vulnerabilities, we will skip how the routing works. The RIP is a dynamic routing protocol that allows routers to exchange information about their connected networks. This is something to look very like, okay, hi Alice, can you tell me which persons you know, or which persons are sitting close to you? This is something because as long as I know who are sitting close to you, then if I were to talk to them, I can just pass the message to you and ask you to pass the message to the people sitting close. And that's my signal. And also try to find the optimal cost to reach different destinations. And for example, there are 3 connected devices, A, B, C, and each one will have a routing tables. They calculate based on this table to decide which devices they should forward this package. And also we will not go into the details. It's kind of complicated. I think, and this also this is something called that I can say it's called the tree of knowledge. I will not open this one. I will not open this one. Just as that, this routing table is to guarantee these 2 functions, and that's it. We will not go to deeper these details. And suppose that we have a router A, B, C on the networks. Each connects to different sub-networks. That means that one of them are just gateways. Router A advertises is not able to route B. I have to introduce this one slightly, just because there are some kinds of vulnerability inside this kind of mechanism. Router A advertises its routing table to route B, which contains a route to its connected network with a hop count 1. And route B received this update F1 to the hop counter. Because after one hop, we know that that life of time of life will be decreased by 1. And that's somewhat similar to this hop count. Update is table if this is a better route. Route B then can advertise its update table to neighbors, route C and route A. Tell them that I have updated my route table, you can have a look. Route A might receive update other than but that it doesn't directly connect. If any route is lost, top 9, route B will send a trigger updating, marking the router edge as unreachable, allowing other routers to update their tables. Okay, and about the text. Again, all communications in this kind of routing protocols are that we assume that all devices they will exchange or communicate some correct messages. Okay, they are all honest router or they are honest gateways. They will send only correct messages. But when considering security issues, RIP could be vulnerable to several attacks due to its simplicity and lack of the robust stuff. And it's called a spoofing cheating, route or drone route information injection. In this kind of attack, an attacker can send fake RIP update message to a router, claiming to have a route to certain networks with a low hope. Low hope means to tell people, hey, I know someone, they are sitting very close to me. If you would like to talk to them, you can send a message to me. And this misleads the router into using the attacker's route to reach those destinations. It means that later, when people would like to talk to people, or information will go to me, okay? I will play as the intermediate router. And this router will direct traffic through the attacker, means that the attacker will seize or communicate data. And this can run the reverse stroke. In every man in the middle attack, where the guys can intercept, modify, or stop the traffic. And we have the consequence based on this kind of reverse stroke so we will have the data breaches related to the eavesdrop, loss of confidentiality, and potential service disruption. That's because of the service discount or traffic. So this is something happening on this kind of eye. And here it has the so-called data breaches just because we assume there are no protections on the data. Of course, if it uses some kind of a TLS protocol, there are no data breaches, of course. And another attack is not the first attack is about injection. Injection means that to direct the traffic. That's the main purpose of the attack. Okay? That's the main purpose of the attack. The main results of the attack that the attackers were going to make it happen. The second one is called poison. Poison to add something wrong. In this kind of attacks, the attacker will send RIP information with a hop count of 60, indicating that this kind of route is unreachable for specific networks. This strict router to making next domain router as embedded. As embedded. For example, Alice sits close to me, okay? Sit close to me. And now all routers or communication should just go to me and then go to Alice. Now the attacker tries to claim that all the hop to mine or the counter to mine is somehow like for example the offline try to publish these kinds of broadcast these kinds of incorrect messages. Means that other router will believe that I'm offline, I'm disabled. In that case, then all communication to Alice will not work. Of course, this somehow also relates to somehow to the denial of service practice. Because the router will remove these routers from the table, blocking legitimate traffic from which is intended discrimination. This is somehow, this kind of denial of service is somehow different from the previous incident. Previously, when introduced previous denial of service attacks, it's just because of the victims has used most of its CPU or memory trying to handle some kind of rubbish request. But this kind of denial of service attacks is more like they believe that this server doesn't exist. Okay? They have done something to make it that this victim is not available or disabled or disappeared, such that there's no more service. The second protocol, the last supporting protocol I introduced in this subject is called BGP. BGP is another routing protocol. It's similar to RIP, okay? Similar to RIP. And the routing text is also quite similar. But compared to BGP and RIP, BGP was designed for large scale internet network routing, especially between these kinds of autonomous systems, something like our internet is primarily used by ISP and large organizations to manage cloud across the web. So how to understand this kind of work? This kind of internet service provider is something like that. Suppose I'm a big company, right? I have my own internet networks. And inside my networks, I should have a route table. Now, another ISP, another internet service provider, also has a big networks, is also managing many networking devices. Now, these two ISP would like to exchange the routing information. Make sure that one devices belong to the first ISP and the second device belongs to the second ISP, they can still communicate. Okay? So this kind of BGP protocol is somehow working on a higher level routing. So and for these kinds of RIP is more likely used for local area networks. More used for local area within the ISP. And RIP is simple, it uses small networks, but BGP is used for a large networks. And this is just this is not about the security of it. It's just some of its very basic or brief introduction to the difference between RIP. And this picture, this picture is not important, okay? But I need to put it here in case there's something. There are some kinds of applications. I'm not going to introduce you detail. Just to tell you that how it works on intelligence inside the BGP are somehow different because they are working on different levels, and BGP have to work on more complex routing information. That's why the detail intelligence somewhat different. It has a sort of similar. The difference is that they use the so-called pass-through vector mechanisms, and this will allow these functions to be larger. And this, and of course, there also has some similarities and also some mechanisms are not. Okay, and about this kind of text. The text is all similar, okay, but the purpose are slightly different. It's called a session hijacking. This kind of text refers to unauthorized takeover of a section between the users from a different network. This takeover can happen during the message when the text capture section identifier, while in the second the communication between the users and this kind of section hijacking can occur through this kind of the PHP because it's operate on the trust-based model. As I said, every information communicates over this kind of IP and BGP are assumed to be honest. This kind of text allows router to accept router updates without strict notification. And attacker, SP, can hijack router by advertising fake paths for IP prefix as they own, redirecting traffic through their own route. This step, previously there's one communication, but for now one communication, it doesn't need to use my service. But I try to change the route information, make sure that that communication will go through to my service. And that's called a section hijacking. Because it will redirect the traffic through their own router. That's okay, let me explain this one. I'm one of the service providers. There's one communication between Alice and Bob, right? But because they have the communications, their communication doesn't need to, or their package doesn't need to go through my intermediate router. But I try to run this kind of picture for local and update the router information wrongly. And make Alice and Bob believe that when they communicate, their package goes through my intermediate router. That will save more time. And then I means that after that, I'm able to see or communicate message between Alice and Bob. And this kind of attack enable the attackers to intercept sensitive information between Alice and Bob, such as the section tokens or some other sensitive information. Means that I can run the eavesdropping attacks on Alice and Bob. And that's the section hijacking attacks. Okay, and these are the last supporting product I have mentioned because about this the vulnerability. And the next one is the IPsec protocol. And let's just have a break. Okay, have a break. Then let's finish this. Let's have 10 minutes break.